from many systems, different formats, very difficult to use them. And writing registry every time, it doesn't work. So how do we make it machine readable so that we can view some statistics? And plus, now the log analytic infrastructures has more diversity. We have Elasticsearch for the searches, Prometheus for time series data, Kafka for like application PubSub style log publishing, and of course Hadoop for big data analytics. Then we need to control where this log should go. Which system should log to there? Which system should receive that data? We need to control that. And we have many applications on the left as well. Many applications, many kinds of applications, many kinds of storages. Then we have n by n arrows there. We need to control this complexity. And you can imagine this mess. So there are n by n scripts. This system sends data to that system using this script. This system uses this config file. Then there are many, many config files, which is almost impossible to manage. So, Friendly comes here. We now can have a centralized logging system so that as long as you manage this system, everything is managed here. It's a unified system. Everything is connected to Friendly. And Friendly routes the data into appropriate places. And it takes care of some complex work in the logging system. So let's go into more details of Friendly. So this is the most important thing in Friendly. Friendly has 500 or more plugins in open source ecosystem. So there are this many output plugins. Well, this is just a part of that. But if you want to log data into, let's say, MongoDB, just install one plugin and then everything goes well. If you want to copy the same data into, let's say, Datadog, you install one plugin and it works. There are also input plugins so that you can integrate other systems to Friendly. Using these many plugins, you can unify as many systems into one unified layer. To achieve this modularized system, Friendly has these many layers in it. First, Friendly receives data using input plugins. Then it applies some filters to convert the structure or add some data or encrypt or compress the data. Then Friendly buffers the data. And for each period, it flushes the buffered chunk into the output using output plugins. All of those four are plugin-based. You can change many, you can choose appropriate plugins for each data flows. And one event in Friendly is all structured. So one event has time, tag, and record. A record is JSON. And using that tag, you can route the events into appropriate place. And structured logging means that, let's say, a text log is coming from Docker container. It outputs, this is a test message, okay? And Friendly filter plugin can add many information there. Let's say, this log is generated on this host, and pod name is that, and container is that. And then once we store this data into, let's say, Elasticsearch, we can filter by hostname. Let's say, is this host saying before? Then we can debug it. You can utilize it for debugging or support. This is machine readable ones. And containers have native integration to Friendly already. Friendly has native logging module by default. You install Docker, then it already has native connection to Friendly. Actually, you have -- Friendly logging, then it sends data to Friendly. Kubernetes also has. And Google Cloud Platform, which already uses Kubernetes, has Friendly as the logging system agent. OpenShift, which is by Red Hat, is using Friendly as the logging aggregator. So now Friendly has actually very large deployment in the world already. And we, Cheerleader, this company, created Friendly. And now Friendly is a part of Cloud Native Computing Foundation. So we are working together with other members in this Cloud Native Computing Foundation. So Kubernetes, Prometheus, Open Tracing, these projects are working together. Okay, so you are interested in Kubernetes, of course. This is Kubernetes meetup. So I will talk about how you can use Friendly with Kubernetes. This is the most basic deployment, I think. You have application server of Kubernetes and some nodes, let's say 2 nodes. Okay? You deploy pods on the nodes. When you want to collect data from those pods, essentially you will deploy Friendly to all nodes. Okay? To do that, Kubernetes has configured a mechanism called daemon set. Once you configure daemon set, the pod will be deployed to all nodes. And you will configure Friendly to read data from the certain directory, I mean, local log files. For a lot of containers, that directory includes logs from the containers. And Friendly reads data as it grows, right? And processes that JSON structure. Then you use a filter plugin called Friend Plugin Kubernetes Metadata Filter. This looks at some information from API server, let's say container name, pod name, those things. Then add that data to the logs. Then finally, logs goes to storage. So, for example, this log was in this file, okay? Then log time was that, and message was that, and time was message that, okay? And using the filter plugin, it automatically adds those information. Host name, pod name, container name, and some labels you set. So, and then in details, you probably need to write. You realize that you need to set up the Friendly, and you set up the daemon set, which is complicated. However, there's already pre-configured image of that daemon set. So just download it and deploy it, it works great. What you need to do is that you set these 2 environment variables, friend elastic host, friend elasticsearch host, and friend elasticsearch port. Then logs goes to there. Good. Okay. On the other hand, most of people need advanced configuration. Let's say the storage is not Elasticsearch. I want to store data to Splunk. Okay, let's do that. Or you have many other logs. Let's say data is coming from some appliances, or logging, you want to log more data from applications directory. Then you need advanced configurations. So first of all, this is a way to configure Friendly in Kubernetes. So first, you will set up config map, saying that friendly.conf is this. I will talk this about later. Then deploy a Friendly pod as a demo set. You will say that Friendly configuration file is this config map. Then this runs on all servers. When you start a pod, you should share a certain directory so that Friendly can read data from the log files. If you want to log data from applications, you probably set up some port as well. And this is one example of that advanced configuration. Let's say you have a patch running on a container, and it produces some logs on the local file. Then Friendly takes it and buffer it locally and send data. When you send data, you want to send data to 3 locations. One is storage data, one is Elasticsearch, and one is S3 for different purposes. Let's say you want to delete data from Elasticsearch after 1 week, but you want to keep data on S3 for years. Then you will put data to 2 systems. You can do that using Friendly just by writing some config files. And this is the config file. So this is a structure of friendly configuration file. Source means a data source. Match means a output. And for each source or match tag, you will say type. Type is the name of plugin. In this case, I'm using a plugin called tail, which reads data from a file. And I'm using another plugin called copy, which copies data into multiple other plugins. Then that other plugins are Elasticsearch and WebHDFS. So in this case, we read data from a file and pass the data into copy plugin. And the copy plugin pass the data into Elasticsearch and WebHDFS. And in this configuration file, the match section has expression, web.aster. This matches the tags of the logs. So in this case, data coming from the about file has tag web.access. Then this match section, web.aster, matches with that tag name. So that data goes to this match section. You can also add many tags there. Let's say application.something, my server.something, or network switches.something. Then you can control the routing using this one single configuration file. This forward is a special input plugin. This input plugin can receive data from libraries, friendly client libraries. Your application directly sends data to friendly with some tag and code. And you can also send data from friendly to another friendly using this forward plugin. Buffering on disks. So friendly by default buffers data in memory. Buffering is actually very important for logging because the network or storage are not always stable. If the storage is overloaded, you cannot store data for a while, but you do not want to lose the data. So Friendly takes care of that. Friendly buffers data for a while, then send a chunk to the system. Then if it is not available, then keep the buffer chunk, then retries it later. It also works to reduce the CPU load of the system. If you put one record every time, it's too much work for the destination. Let's say Elasticsearch does not have good scalability for small records. Instead, you should put larger chunk at once as a batch. Then Friendly can combine many logs into a buffer chunk, then flush everything as a batch to the system. So for this buffering, Friendly uses memory by default. But using memory means that whenever you restart the server, it will be gone. And because it is memory, it consumes memory, of course. And in fact, in real world, this size of buffer becomes larger. Let's say there's a network trouble, and the network was unavailable for 1 minute. Then it can immediately fill up the memory. So it's not actually a good idea to keep using memory if you are using Friendly in production systems. Instead, we recommend you to use file buffers. File buffers store data in the file, not disk. Then Friendly buffers data on the file, and then it uses the file as a memory chunk. Then you can flush the file chunk to the server. Okay. So with this idea, you can store larger data for buffering. Even if the destination is down for 1 day, 1 week, that's okay. You can keep the data on the disk. You do not lose the data. Then having data on the disk is also good for checking the status of Friendly. Let's say if there are long buffer queue, if there are many buffer chunks on the disks, then you know that the destination is somehow not working well. You will then, this will be an indicator to know the stability of the system. You check the size of the buffer data periodically and send that to Prometheus or something. Then set up a lot so that the system, that you can make sure the system is working well. So, and then this is a configuration file. Buffer type file. This uses file buffer plugin again. Then pass this path to the plugin as a configuration. This flushing table means that Fluentd flushes a chunk every minute. You also have some other configurations here. Let's say if the chunk exceeds 1 megabyte flush, do not retry 2 times within 2 minutes. Meaning that if the system is overloaded, you shouldn't retry too frequently. You can control that retry interval here as well. So buffering is a key of the system stability. Multi-tier log aggregation. So buffering is important, okay? But as you have many small servers, it would be difficult to buffer data because they are small. And then it means that you have more frequent flushing interval. The storage will receive data from many locations. Right? You have 100 servers. You have one storage server. Then this one storage server receives 100 connection. 100 should be okay, but if you have 1,000, that will be difficult. Okay. So to manage this problem, this many connections problem, Fluentd has aggregation, meaning that you have edge-friendly servers, meaning that applications are running there and Fluentd is also running there together in the same machine. You prepare another tier, the second tier, which receives data from those edges and buffer there. Then aggregates that every minute or 10 minutes. And then compress it and upload it to somewhere. This makes the system more reliable and more scalable. And when you configure this structure, Fluentd also supports 8-share configuration. One is master, one is standby. Or you can also configure that 60% of traffic should go to this node and 40% should go to this node. And you can also combine the load balancing and active standby configuration. So Fluentd has this 8-share control built in. So there are many people who are using Fluentd. Let's say Microsoft, one giant in IT world, is using Fluentd actually. They are using, they have a logging system called OMS Agent. Of course, they have OMS Agent for Windows, but they didn't have good thing for Linux. But they now have Linux on Azure. So they created their own logging agent on top of Fluentd. Maybe that's good. We are from Cheerleader. We created this tool, but on the other hand, we provide different services actually. We collect data using Fluentd into cloud. We provide log analytics on top of it. Okay, thank you very much. So please ask anything.
Questions? So there's announcement that you have for questions?
Yes, now we have these 3 hoodies, so 3 people will get this. Please
First
ask
3
them.
questions.
the users.
Yeah, first, wait.
Yeah. How can I dynamically route logs, so I guess individual log messages to different outputs based on some sort of class? So for instance, if I have a Kubernetes cluster with a production and a development namespace, perhaps I want logs from pods running in the production namespace to go to a separate ELK.
I see. So one idea is to use a special plugin, output plugin called Forest. It generates plugin instances dynamically. As it receives new log, it matches with certain rule, and depending on the rule, it creates output plugin dynamically. So it's a one way to dynamically configure it. The other way is actually just deploy a new configuration file and restart it. You may think that it may cause some downtime. However, the newer version of Fluentd, which will come soon, supports dynamic restarting. It keeps port opened and creates a new instance with shared port, and it does not cause downtime when it restarts.
Except in this case, right, if Fluentd is reading from, varlib Docker containers, how will I be able to, in the configuration file, tell it to, for instance, this set of pods send to this output? I mean, right, it'll identify
Yes.
based on container ID. So it's
Yes. So to do that, Fluentd can have filter plugins. So first, data goes to a filter plugin, and you can put some rules saying that if this event has this data, goes to this tag, right, then you can read it.
Great. Thanks.
Thank you very much. Very good question.
Thanks a lot.
Okay, second question. I'll get to you. The third question is yours. This guy here.
My question is, you showed the demo of the config file running a daemon set on the machine,
Yes.
so that reads var log containers. And you also showed some Apache logs.
Uh-huh.
How a daemon set can read Apache logs inside the container?
Yes. Two possible ideas. One is to share a volume. This is, I think, the easiest. I mean that this pod and this pod share the same directory, and this pod writes data to this directory, and this pod reads data using Fluentd. So that's the easiest idea. The other is to install some lightweight data forwarder. And this forwarder runs together within the same pod, and this forwards data to a Fluentd aggregation server. So there are some lightweight log forwarders. One is called FluentBit, small Fluentd. So it can read data from file and send that data to a Fluentd instance. There we go.
So, are we supposed to clap when someone gets a...
So in one of your slides, you show that Fluentd supports, let's say, HA configuration, and you could actually configure the different rules in terms of percentage, how much traffic you would like to send to one node and how much traffic you would like to send to another node.
Mm-hmm.
So is this configuration of the Fluentd, or I have to set up my own load balancer and configure that?
You will set up that weight.
So it's on my own.
By default, it distributes data evenly. So you can change that to weight, so that, let's say, new server has more CPU.
So it's not part of the Fluentd.
It is part of Fluentd.
It is part of
It is
Fluentd.
a built-in Fluentd feature, so that you can load balance evenly or have some weight across multiple Fluentd instances. So yes, it
Okay,
is a
so I
Fluentd
can
feature.
configure the weights for the Fluentd.
Yes.
Okay, thank you.
Here's another co-founder, by the way. All right. Thank you very much for that question. There we go. Thank you.
Can I have one more question?
Without foodie.
Without further question.
We have one more question without the hoodie.
So, I'll refer to the question that the guy had at the previous presentation about tracing.
Mhm.
So we've been talking about actually aggregating the logs, but what about the content of the log messages? There's a thing called open tracing.
Mhm.
What's the status of that? Are they making headway in terms of getting the readable data
Mhm.
out of the log messages?
Do we have some stories about open tracing plus Fluentd? Not yet. Probably not much at this moment.
It's a good question, and yeah, probably we will try to see if open tracing or Prometheus, someone can come and talk about that. which would
Oh,
be great.
nice.
I think open tracing is more.
Can you
for-
use this?
Oh yeah. I think open tracing is more for performance diagnosis or anything, for example. But it's more for metrics collection, and Fluentd comes in from like mainly the angle of log collection, right? So you can use Fluentd for metrics and log collection, but it's mainly log. Now, open tracing comes more from like performance diagnostic, correlating multiple traces of like performances and then logs and then correlate together as a one transaction, right? So there is some gray area around, but it has its own strengths, and then we actually don't have a good story around about how to unify between us. And I think working as a CNCF project, we typically has like a weekly meeting presenting by the different project and such. So in fact, Kubernetes people, Prometheus people, Fluentd people joining together and working together. I think for the future, we have more unified story and usage.
Hi, I'm the person that asked the tracing question the last time, and what we're looking at doing is using the trace ID and putting that into the log, each log message. So basically that's at least you have the key, but you don't have the system to tie it together. So the system becomes so the tracking the two together becomes manual, but at least the data's there to do it with.
Thank you.
We are done with officially with all the questions, all the sessions. We don't have a third speaker, so we have Mark and Ankush and Sada here available. More people from Treasure Data or Fluentd, and a lot of people from JFrog. So you can mix, talk to each other or talk to them, ask questions. The floor is open. The meetup's done. Bye, guys. And if you guys want to post, participate, reach out to them. Thank you.
It's really